In order to solve this problem, let's first put these two into parts. So let's call this part A and let's call this part B. So we're given two parametric equations, x of t and y of t. So part A asks, express the slope of the tangent line to the motion of the projectile as a function of t. So tangent line we know is derivative, so we must set this as dy over dx equals, and then find the derivative of each part. So in this case, it would be VO sine of theta minus g of t. And this can be found using our basic derivative rules over VO cosine of theta. So that's already part A. That was easy enough. So now at what time t is the projectile at its maximum height? So as we've learned before, maximum height is when dy dx would equal 0. Because if we graph this, we can easily graph this. We can graph a parabola right here. So we want to find this. We want to find this tangent line at this point. So in order to do this, we must set dy dt equal to 0. Otherwise, as 0 equals VO sine of theta minus gt. So we have to find what t equals. So using basic arithmetic, we would get t equals VO sine of theta over g. So now, what we could do, if you wanted me to break it down, I could add the g of t over, so it'd be g of t equals VO sine of theta, and then just divide the g over, and then that would be t equals VO sine of theta over g. And these are your answers to part A and part